Ladies and gentlemen, welcome to this webinar of the World Bioenergy Association. We will just wait another minute until we kick off in order to give everybody the chance to enter the meeting room. I think we can start. So welcome everybody to this webinar that will investigate on the opportunities to earn money from saving the climate. My name is Christian Rakosch. I am chairman of the World Bioenergy Association, and I'm very glad that we have three excellent experts on carbon markets and then that will elaborate on the possibilities to make climate protection a profitable business. It is Henrik Schult from Carboneer, a carbon consultancy that is helping companies to deal with carbon markets. Henrik Harrison is coming from the company Yard that is also trying to do actively business by producing carbon reductions. And Robert Müller, he is a consultant and he has a deep insight in the application or in the use of carbon markets for clean cooking projects. So this is the lineup of today. We have a lot of participants. That's great to see the interest in the subject. And before we start, let me just very briefly introduce the World Bioenergy Association to you. For those that have been, or for those that are here for the first time, our association is a global one. We have members across the world that are either active as associations dedicated to bioenergy or as companies that are doing business in this field. And our mission is the sustainable development of bioenergy globally. We do so by sharing know-how, like in the webinars that we're doing, by providing platforms for our companies. We publish annual global bioenergy statistics, and we participate in diverse international organizations and participate in international conferences such as the Climate Conference. So much for our organization. And now just an advertisement for the next webinars. We will have a webinar in a week that will investigate what it takes to deliver and produce certified sustainable biomass. I'm sure you're aware that in many cases, certification of sustainability has become a key criteria actually for delivering bioenergy. And we have designed this webinar with a company that is very, very knowledgeable. It's the Sustainable Biomass Partnership that has developed a certification scheme that is widely used, and we will look at this topic. The next, after this webinar, will be dedicated to sustainable aviation fuels and the question, what would it take for sustainable aviation fuels to take off? And we're doing that together with the Asian Association for Sustainable Aviation Fuels. If you find our webinars interesting, you can look at what we did in the past. We have a whole series of webinars with excellent speakers, all on our website available as both with the recordings as well as with the presentations that our experts made. So you can also look what we did in the past. So let's kick it off, and I will hand over to Henrik Schult from Carboneer. Henrik, the floor is yours.
Perfect. Thank you, Christian, for the warm introduction. Let me just start this sharing. Just 1 second. You should be able to see my slides now. Is that correct?
Perfect.
Right. Thank you. It is my pleasure to be here and to provide a very, very brief impulse on how carbon markets can be utilized to generate some revenue streams for bioenergy projects. My name is Hendrik Schultz, and I'm a managing director at Carbonier. We are a Berlin-based consultancy company focusing on carbon markets, basically on two aspects, on compliance markets such as the European Emission Trading System, the EU ETS, and other mechanisms such as the Carbon Border Adjustment Mechanism, CBAM, or the Green Claims Directive. And on climate neutrality and negative emissions, which will be or is our second focus area. And here we really focus on carbon management technologies and practices using durable carbon dioxide removal techniques. For both areas, we do provide strategic advisory and operational support to our clients. And always when you're concerned with carbon markets, it's very important to understand that in these market-based approaches, there's different sources and different sinks of CO2, and they do play a role when we are talking about carbon markets. The type of CO2 that most people here are likely familiar with is fossil-based CO2, which is emitted into the atmosphere through various economic activities. Then in addition to that, there is fossil-based CO2 that is captured and returned underground via carbon capture and storage, or CCS. And then we have carbon dioxide removal, on the other hand, which refers to the physical removal of CO2 from the atmosphere and its storage in other things such as, for example, the biosphere or underground reservoirs. And lastly, there is CCU, carbon capture and utilization, which basically captures CO2 from various sources and binds it into products. And this figure here is it's very illustrative. In reality, each of these concepts includes a range of technologies and methods. And these different forms of CO2 are treated differently across distinct markets for CO2. And it's also worthwhile to have a brief look into what these markets actually are and what are they dealing with. And carbon markets can basically be divided into three categories. We have compliance markets, voluntary markets, and markets for molecular CO2. Compliance markets, such as the European Emission Trading System, I already mentioned it, they primarily aim at reducing emissions in line with national and international climate targets. However, this distinction becomes increasingly blurred as the system is being expanded to also account for the other three forms of CO2, so CCS, CCU, and CDR. Then we have the voluntary carbon markets, which are mostly used by companies aiming to achieve climate neutrality on their balance sheets, right? So in these markets, these companies make voluntary payments to procure so-called credits, which are offered by climate protection projects, which will generate these emission reductions and then sell these to other companies. And these projects oftentimes focus on avoiding emissions, but do also include physical CO2 removal, such as, for example, in the easiest case, afforestation. And here too, the rules and definitions are evolving to better incorporate CDR, carbon dioxide removal solutions, and also CCUS in the future. The markets for molecular CO2 serve industry like, for instance, the beverage sector, which has a direct demand for CO2. And here it's very important to close the global carbon cycle. It is very important that these CCU technologies will be used in the future to meet the demand for carbon. Now, for a brief example, I'll take you to a short excursion into the EU ETS, the European Emission Trading System, and just one example how bioenergy can be treated on this market. The core principle of a cap and trade system, the European Union Emission Trading System is a cap and trade system, and the core principle is very simple. We establish a fixed cap on total emissions from companies that are active in the sector, which is covered by the regulation. And this cap is then reduced annually, aligned with long-term climate goals. And this declining cap then over time will ensure that the emissions decrease, creating a predictable path towards decarbonization. The system targets large industrial emitters such as power plants, steel mills, or cement factories, all from the energy and emission-intensive sectors. The companies regulated under the EU ETS, they must surrender one allowance, which is called European Union allowance in this system, for every ton of CO2 that they emit to the atmosphere. The allowance prices are then determined by supply and demand, basically, at auctions handled by governments or on secondary markets where these allowances can be traded among market participants. These companies, they can buy and sell these allowances, they can bank these allowances, giving them some form of flexibility in how they meet their targets. And this trading in allowances generates then a price, which is depicted here on the right. The figure shows the historical prices in the EU ETS together with some projections for the future. Now, currently, we are roughly at 70 euros per ton of CO2. And you can see that this is a very volatile market being influenced by politics, by reforms of the sector, by updates of climate targets, and so forth. So now let's try to figure out a way in which biomass can help to reduce the financial obligations under this emission trading system. And let's take a practical example from steel production. Imagine we are operating a blast oxygen furnace using sinter and fossil coke to produce some hot metal. Since we are producing in the EU, we are subject to the European emission trading system, which means we must purchase and surrender allowances for each ton of CO2 we emit. Now, what happens if we reduce the amount of fossil coke and replace it with biogenic coke? Will this eventually lower the cost that we incur due to the European emission trading system? And the simple answer is yes, it will. If we use the biomass as a process material, as a reductant in the process of steelmaking, the resulting CO2 emissions are considered biogenic and are then deductible from the emissions that require allowance. So the more biomass we actually use, the fewer allowances we need to surrender, which directly reduces our compliance costs. What if we burn the biomass to generate energy instead? And that can also lead to cost savings, but only if certain conditions are met. And you can see these conditions here. It's all getting a bit more complicated, but I'm really just trying to get to convey the idea to you. Right? So there is a certain threshold in the size of the facility involved, and there's also certain sustainability criteria which are to be met if the emissions are supposed to be deductible under the EU ETS. So these sustainability criteria come from the RED, the Renewable Energy Directive. So then it gets a bit more complicated, but in principle, it's still very much possible. And then there's also a hybrid case where biomass is used both as a process material and as a fuel. And under certain circumstances, also these biogenic emissions can be deducted from the ultimate emissions. So the key message, the key takeaway really is substituting fossil materials and fuels with biogenic alternatives can actually lead to real cost reductions under such systems. Right? It always depends on the exact policy design, on the requirements, on monitoring, and so forth. But you can see here in the EU ETS, it's very well possible. And this most certainly strengthens the business case for biomass in industrial decarbonization. For example, to make it more concrete and relevant to today's topic, I'll focus on one specific carbon dioxide removal pathway, which is bioenergy with carbon capture and storage, called or abbreviated BECCS. And before we dive into it, let me explain why the concept of carbon dioxide removal offers some basic advantages on voluntary carbon markets compared to conventional offsetting projects. So many of these methodologies used to account for emission reductions of international climate projects were developed during the Kyoto Protocol era. And at that time, many countries had actually no binding emission reduction targets, right? All these gray countries you can see on the map, they didn't have any targets. And as a result, any emission reduction in a country or in a sector without a binding target was considered additional, meaning that the reduction would not have occurred without the international climate project. Now, under the Paris Agreement, nearly all countries have submitted nationally determined contributions, which potentially cover all the major sectors within these countries. And this means there's now very little room for international climate policy, international climate projects to deliver emission reductions that are truly outside the scope of government targets. So any emission reductions achieved by a project would likely also be counted towards the host country's NDC, leading to so-called double counting, right? Imagine a private actor doing a afforestation project somewhere in Latin America, then certainly CO2 is sequestered into these trees. They will go on and sell these credits on the voluntary carbon markets, but at the same time, the government, the national government, might claim these CO2 sequestration in their inventories. Right, and as shown on the right here, it has become a very complex and technical process to determine whether an international climate project can still generate these valid climate offsets, right? Or whether it's rather one of the alternatives would be a climate contribution claim, where you can claim you contributed to the goal, but you cannot really make a claim that you're climate neutral now. And one key requirement here is the use of corresponding adjustment. And this is a system where basically the host government then will agree not to count the emission reductions from the project in their own national greenhouse gas inventory, right? Instead, the reductions are transferred to the buyer country or the buyer company, ensuring that there's no double counting. So you can see this is already very complicated. This is being dealt with still within this frame of the Article 6.4 negotiations, but this is yet to be resolved. And some of the carbon dioxide removal technologies are inherently more robust to double counting than these conventional offsetting approaches. And this figure here shows a spectrum of CDR approaches ranging from the nature-based solutions like afforestation or biochar to the very engineered solutions like direct air capture with carbon storage. And we can also see that these technologies differ across several dimensions, such as permanence, or costs, or co-benefits. And also different users might prioritize these criteria differently. We do have currently a wide range of actors, governments, international bodies, and private initiatives that are developing standards to help accurately measure and verify these emission reductions done by the CDR projects. And the reason now that some of these CDR projects are less prone principle to double counting is that their carbon sinks are not part of any national greenhouse gas inventories, right? And therefore, they cannot be claimed by government. So for example, with bioenergy and carbon capture and storage, this BECCS, CO2 is stored underground in geological formations, which are not monitored or reported in these national inventories. And that makes the climate benefit of BECCS easier to attribute to the buyer, the company, of the carbon removal credit without any overlap of government targets, right? And here you can see the basic principles of BECCS. Basically, biomass is combusted to generate energy, and the resulting CO2 emissions are captured, stored underground. And then the facility operator can sell both the electricity and the resulting carbon removal credit on the voluntary carbon market. You also see some statistics on the right from looking at the cost. And the other figure, you can see that this is a rather cheap technology compared to the other more engineered available solutions. And the bottom figure, you can see that it's quite dominant in terms of the volume that has been put under contract on the voluntary carbon markets, which is certainly due to the fact that these facilities require a lot of CapEx and are therefore rather large. So that's really not a surprise. It's just really here to give a quick overview. Right, so bioenergy plays a growing role in carbon markets, but its potential comes with both opportunities and constraints. As for instance, global CO2 prices increases, the economic viability of bioenergy applications increases significantly. And at the same time, the shift towards low carbon technologies enables the development of new business fields or new business models. There are also challenges. For instance, the European emission trading system imposes extensive monitoring and reporting obligations for biomass use. So this is a burden for the companies, and these obligations are especially relevant if you have to look at sustainability of the biomass sourcing or the emissions accounting. And perhaps the biggest constraint, many of you are aware of this, obviously, is that scaling bioenergy is limited just by the availability of this resource, which is scarce in a highly competitive sector, right? Thank you for your attention. I understand we'll have some time to take in questions. I also understand that you will be having access to the presentation slides if needed. So yeah, I'll leave it here.
Thank you very much, Hendrik. That was a beautiful overview on what different aspects and how complex actually carbon markets are. And that gives us an excellent overview. Before digging a little bit deeper into how we can utilize these markets for specific technologies and for specific uses. I am just looking whether there are some questions here already in the chat. So let me see. Please, whoever has a question, write it in the chat and we can deal with it. And we'll deal with the questions always after the presentations. So there is a question from Peter Sommerer from Vienna. And he is asking, what is the relative size of the compliance market versus the voluntary market? Can you comment on that, Hendrik?
The compliance market is significantly larger, right? So also there's not the compliance market, so you'd have to add up all compliance markets from around the world. If we are talking about the European emission trading system, I think at the moment the annual cap of emissions, it's 1.4 billion tons of CO2, something like that. I'd have to look it up. And voluntary carbon markets, the global ones are just smaller than that. So compliance markets are just a different order of magnitude.
Right. And that applies not only on the size of the market, but also on the price of carbon, correct?
Yeah, for the price of carbon, it's a bit different. So, I mean, only looking at the European emission trading system, we have a uniform price, obviously, whereas on carbon markets or voluntary carbon markets, we have various prices, right? It always depends on what exactly you're looking at, which technology, which region, on other quality criteria of the project, right? So, I mean, some of the lower price credits start at the couple of dollars per ton, but then you get what you pay for. And then on the upper end, it reaches, as you have seen in the picture, it reaches 4 digits per ton. If you're now looking at the engineered solutions of CDR, for instance.
Another question is asking, as biochar is the cheapest technology, why is it not widely applied? Why don't we see more projects?
We are seeing more and more biochar projects. Certainly not the cheapest technology. Maybe it was amongst the cheaper technologies in the pricing data I just shared. But comparing it to, for instance, 1 ton of CO2 that is saved through afforestation, biochar is going to be very expensive, right? Even comparing it to some of the prices that we observe from compliance markets, biochar is still relatively expensive.
There is a question on what opportunities there are for African countries to participate in carbon markets. And that question, Lizzie from Nigeria, that question is going to be answered, I think, by our next speakers. So we'll leave it for them so that they will give you some excellent examples of that is how that is possible. So last question I'm going to take is, can you say something about existing verification systems and their quality and the status and role of the European carbon removals and carbon farming system? So
yeah,
verification. How do you, I mean, you're selling this for money, your CO2 emissions, somebody needs to kind of verify that you're not joking.
Yeah. So I mean, just picking developer, just picking a standard that you would like to adhere to can already be a challenge. As you know, there's quality differences among these standards. Many of you are aware of the headline some of these organizations made during the last years. So that can already be a challenge, and this is certainly worthwhile to sort of pick the right standard that's suitable for your project, right? Just to give you an example, Christian, we were talking about durability earlier, right? So there's standards who just will not account for any CO2 reductions due to afforestation, right? Because it's deemed not durable, right? So they will not certify it, whereas others happily do so, right? So you'd always have to pick a standard of, regardless whether you're on the seller or on the buyer side, right? You have to understand what is the standard standing for, and then exactly how is it verified, who does the actual work, right? So that's very important. And unfortunately, there's just no general answer to that question.
Wonderful.
I'm not sure whether we have time for the other part of the question on the CRCF. The brief answer is we are moving forward. So we are looking forward to having this, which is nothing else but the standard, a couple of methodologies telling us how to account for emission reductions, which is very much needed in the sector, especially from the CDR community.
Thank you so much, Henrik. I will use this opportunity to briefly point your attention to a post that was just made by Dorotha from Bioenergy International. Bioenergy International is the official magazine of the World Bioenergy Association. It's a brilliant publication. You can download the app and you can have a look at this very relevant publication on bioenergy. So this is a little bit of a sales pitch from my side for Bioenergy International. So please look it up. Now, the next speaker is Henrik Harrison. He is head of business development and growth of Yard, a Swedish company that is trying to make carbon reduction a business. Henrik, how are you doing that?
Thank you, Christian. Let me just share my screen here, and I will get right to it. Share. I hope that you are all able to see the screen here now.
It's good if you just do full screen.
Yes, excellent. Like this? Now you can see?
Yes, perfect.
Perfect. All right. Thank you, Henrik, for an excellent presentation. A lot that we can agree about there, I think. I'm Henrik Harrison, and work with the development and growth at Jord. We have been asked to talk a bit about Jord, and I am actually very excited here to be here to share what we do and give you all, I think, a glimpse into the role that bioenergy projects can engage with the carbon credit market. And I personally think that Jord is a wonderful story to tell here, because it's a bioenergy project in the foundations, but it has been built with the purpose of restoring and rebalancing the carbon cycles, focusing a lot on carbon credits here as well. So I can start with just telling you a bit about Jord. We are a Swedish company. We are based in Stockholm, and our mission here is to help to restore and rebalance the carbon cycle by restoring the biosphere and deliver renewable product. And we really do believe in a future free from fossil fuel emissions. And that is why this business has been built with the intention of tapping into the power of nature to produce renewable biofuels. And we do this specifically by using degraded or otherwise marginal land to not compete with the extremely valuable farmland that is needed for food production. We also don't rely on forests. So those two sets us apart a lot from other bioenergy projects. Instead, we grow C4 grasses on these marginal or otherwise degraded lands to create the biofuels that we need, and in that process also generate a carbon dioxide credit. And what we do here, we have two sites, establishment and operational, working on today a combined 570 hectares. We produce a solid fuel pellet along with carbon credits. And an annual production capacity of around 40,000 tons of fuel pellets and about 50,000 tons of carbon credits. And to dive a bit deeper here is maybe to talk about first the challenges that we face. And I think that what we really build on is that the carbon cycle is out of balance. And this has been forced by too much emissions, by unsustainable land use that are putting real pressures on our environment and on the planetary boundaries within which we all operate. And Jord, we are tackling or addressing three of these problems simultaneously. It is a heavy dependence on fossil fuels that we still rely on a lot today. It is the increasing levels of CO2 in the atmosphere, and it is degraded land that is unfit for food production. And what we aim to do with this solution is to create a healthier planet by aligning with a natural carbon cycle and supporting communities and achieving sustainable outcomes across the cycle. And to the solution, our holistic approach is based on what could be seen as a 5-step process. So Jord goes in and establishes plots on marginal or otherwise degraded lands and implements a regenerative farming model. This regenerative farming model is based on the crop C4 grass, which absorbs carbon dioxide, stores that carbon dioxide into the biomass itself and into the root systems through the process of photosynthesis. And Jord transform that C4 grass, harvest it into a solid biofuel, and sell it to companies that today rely on fossil fuels. That way, we can help companies to shift from the unsustainable use of fossil fuels to a renewable solid biofuel. And this process generates two types of validated carbon credits. It's a soil sequestration credit and a fuel switch credit that companies can purchase to reduce their hard to abate emissions. And Jord locations. We are mainly operational in the Dominican Republic, where we have our flagship project. We're operational on 500 hectares with an annual biofuel production capacity of 20,000 tons as of right now. And we see a huge potential in the country. The country has been really, I wouldn't say, but well, maybe devastated by deforestation and by unsustainable sugarcane operations. So there is a lot of otherwise degraded land in the country that is fit for Jord solid biofuel production. And we are also establishing in Senegal, where we currently have 70 hectares. We have had an announcement today, actually, that we have been awarded another 300 hectares in the country to continue to establish our solution on. So these are our two production sites as of right now. And these images shortly describe the process here. We establish on the land, we plant the C4 grass. We have a short growth period, and the grass grows up until 5 to 7 meters. Then we harvest it, and this procedure is circular. It's not an annual crop, so it can just continue to grow after the harvest, and it is continuously turned into a solid biofuel. And talking about the impact from this bioenergy project, as I said, 20,000 tons of pellets produced annually. We have 20,000 tons of brown coal that could be replaced annually. We can produce carbon credits from the avoided and the removed carbon dioxide, and we restore degraded land and create jobs in the areas that we are operational in. So that's a little bit about the, amazing impact really that bioenergy projects can have in regions where they take place. And so a little bit about carbon credits then, and how you and other bioenergy projects can benefit from them or engage with the carbon credit markets. Bioenergy projects really offer a dual benefit in the carbon market. And the first one is in projects like ours, they help to avoid emissions by replacing fossil fuels with renewable alternatives. And secondly, depending on the feedstock and process, of course, they can also contribute a lot to the carbon removal part, for example, by sequestering carbon in root biomass or in the soils. And we really think that this gives bioenergy projects a really unique edge, the ability to qualify for credits under multiple methodologies, both emission reductions and carbon removal pathways. And projects like yours, where grasses are cultivated on degraded land and converted then into renewable fuel, present a powerful example. And not only are we preventing new emissions by displacing coal or oil, but we are also drawing carbon down from the atmosphere and locking it underground through the natural processes. And it's really about being able to take a, I would say, holistic approach here. Because let me look on the next slide here. There is really a huge financial opportunity for bioenergy projects to actually generate revenue or to get financing from the carbon markets. And I would say that the most direct way is by generating carbon credits. And they represent either reduction or removal of 1 metric ton of carbon dioxide. And for any project that is engaged in bioenergy, the key here is that these projects can often stack revenue streams. So there is a financial additionality requirement to carbon credits in the voluntary markets. But when you sell the biofuel itself as a renewable energy source, you can separately monetize the environmental impact through the sale of carbon credits. So there is stacking of the revenue sources available with the carbon credits, but the financial additionality requirement makes it so that the bioenergy side of the business model cannot oftentimes be higher than there must be a negative net IRR, so to say, according to some financial additionality requirements today. And the bioenergy is, I would not say, no longer really about replacing energy sources, but it has become more about unlocking value from the many environmental services or products that bioenergy projects can really provide. And just to close it up here in this slide, I want to leave a few strategic insights for those developing or scaling bioenergy projects around the world that's aiming to participate in carbon markets. And I would say that it's extremely important to start with a robust baseline. And that means to just clearly document what emissions would have occurred in a most methodologies say business as usual scenario. You have a credible baseline, which is the foundation for providing this additionality requirement. And additionality is really what makes a carbon credit valid. And then you have monitoring, reporting, and verification. And it's essential for all projects, both in compliance and voluntary markets, to really invest and get a really high integrity MRV system in place, because without high quality data and the traceability that comes with that, your credits will achieve zero trustworthiness in the market and might not even be certified. Third is to align with sustainable development goals, because we have seen that buyers increasingly prefer credits with verified co-benefits. such as, well, for us, it's biodiversity restoration, it can be water conservation, it can be community development. So these types of projects can really set your credit apart from other projects. And in some cases, when we have talked to marketplaces, it can even command certain price premium as well. And focus on aligning your measurement with the market standards, such as the ICVCM, Integrity Council for Voluntary Carbon Market, or up and coming or really established places like Pure Earth, to really get yourself better positioned when you issue high integrity carbon credits. This will give you access to another type of premium buyers. And I think I leave off there. Well, thank you for listening in. Any questions, I'm happy to take them. Yeah, if you want to get in touch, you can contact Rocio Lopez here, and he will get you to me if I say like that. Thank you very much.
Thank you so much, Henrik. Very interesting and exciting projects. There are a couple of questions here for you. So let me start with the first few. They are kind of addressing what kind of grasses are you actually growing there? Is there evidence that the growing of these grasses really improves the soil productivity? Because, I mean, they seem to grow very strongly. So the question was also raised whether this was really marginal land. And I mean, wouldn't it be better to just leave the wild vegetation? How would you answer these questions? The first two are more kind of practical, and the other one is kind of the general approach.
Yeah, sure. So there are a lot of different types of C4 plants, C4 crops. We are using a variety of them. Another kind that we are not using is bamboo. So in regards to the crop, it really depends on, yeah, we are using a wider range of C4 grasses. So that, yeah, I can't really say more than that to that question. In the general approach, there is always a balance, I would say. If there is, for example, in Senegal, make Senegal as an example, what we do there is that we locate more or less deserts. It's desert land, it's sandy soils, it's really degraded and marginal. And marginal land is not only land that has poor soil qualities, but land can also be marginal that could be used for something else. But local communities or other type of commercial actors are not willing to invest in that land. So it can be economically marginal, it can be infrastructurally wise marginal, but in Senegal it's basically a desert type land that we are looking at for the 70 hectares. And then when you talk about, okay, but what about the current and ongoing carbon activity and leave it to the wilderness? I'm, you know, it's also a balance to be stricken there. It's one of those examples where on the one side, it would be great if there could be anything growing there, but on the other side, if we can produce a solid renewable biofuel that would revigorate the land, increase the biodiversity over time, then why not at least try to do it and see if there is any any sort of buyers, which there are, of high quality biofuel. So as long as you do it not with the intention to maximize biofuel output, but with the intention to optimize for positive outcomes across the spectrum, I think that it is a good thing to try to do it and not leave it for the wilderness to take over. But with that said, biodiversity is extremely important and something that each bioenergy project should strive towards increasing and restore.
Yes, and at the same time, I mean, sustainability includes the concept of social sustainability, and that means
It does.
creating a livelihood for people that are living there, not only for plants and animals. And that livelihood, particularly in Africa, is a let's put it this way, a very difficult and threatened one. And these projects can clearly contribute to that. So I think that's also an answer to the question, why not leave this to the wilderness? There are people living there. So that's the problem. There was another question, and that was, what are the pellets being used for? Can you elaborate a little bit on this?
Yeah, for sure. The pellets can be used for, it's very similar to a wood pellet. It can be used for heat, mostly industrial users to produce heat and energy, industrial heat production for industrial processes to generate electricity. Often times it's co-burnt with other type of biofuel or biomass, but it can be used as a standalone pellet as well. So it's in its qualities, it's quite similar to a wood pellet.
There are a lot of projects in Africa, particularly look at using the pellets, and we'll hear that from our next speaker, are dedicated to use as a cooking fuel. Have you kind of considered that also?
Yes, we have considered it, but not gotten any deeper into it than that, I would say, which is why I'm very excited to hear what Robert has to say about this, so we can learn a bit more about it.
Brilliant. There is another question on the C4 grass. So an example would be miscanthus, elephant grass, napier grass. In principle, corn is also a C4 grass, but I guess that's not what you're going for.
No, that's right.
So there are a couple of them, and they're really growing very beautifully and very easy to plant. In fact, another C4 grass is also sugar cane or energy cane. That is a grass that I find particularly exciting. It's a sugar cane that has been breeded to produce not sugar, but fiber. So it produces up to 40 tons of dry material per hectare. It's extremely strong growing. So these grasses, they do have a lot of opportunities for the future, I believe. I think we should carry on and hand the microphone over to Robert Müller. Robert is working as a consultant, and he has been doing so with particular attention to companies that are involved in clean cooking activities. Robert, the floor is yours.
Thank you. I'm sharing my screen. Hopefully I'm successful. Yeah. Can you see that?
Absolutely, it's perfect.
Okay, so that's the first one. Yes, I'm going to share some practical insight on how it works to develop a carbon project, as I'm a consultant helping projects, cookstove projects and other projects, also mostly in the voluntary market, to get certified and to get funding to fund their activity with carbon credits. So, yep. So cookstoves are, there are many cookstove projects in the voluntary market. It's a typical voluntary market type of project. Most of them work with improved cookstoves that have a better efficiency but do not switch the fuel. So they help to save fuel wood or charcoal. I think we are now more interested in those, what I call bioenergy cookstove projects that use specific fuels like pellets. So it's a nice fit to the foregoing presentation, or also briquettes, ethanol, biogas, and other biomass fuels. So these are most interesting, I think, for the audience, this type of projects. as I said, most projects are under the gold standard in the voluntary market, and my or the project I've mostly been working on recently are micro gasifiers with pellets. There's Supermoto, for example, working in Zambia and Malawi. I know that Matthias Olsen had been asked also to do that presentation. Ecosafi in Kenya, biomasses in Rwanda, and some others. These are all gasifiers fuels that have a very clean flame by burning pellets and sometimes briquettes. But there are large projects like in ethanol stoves and biogas stoves and others. But my focus now is on the gasifiers and pellets. Also under the Paris Agreement, on the new compliance mark, the international emissions trading that is now evolving, these projects play a role, and there are 2 projects under development of Supermoto in Zambia and Malawi under the bilateral agreement under Article 6.2 of the Paris Agreement. So there's a demand for high quality projects in that evolving market. Coke stoves are interesting for carbon because you can fund practically an entire project with carbon credits. This is quite exceptional. If you expect 2 credits per stove in years, and you may have a good price like 10 to 15 euros, that gives you, well, 50 to 150 euros without discounting, but in 5 to 10 years. So that may be the entire project. And if you look at, for example, power plant that is powered with some sort of biomass, carbon funding may contribute maybe 2 to 10%, much less. So this is exceptional. That means that for cookstove projects, carbon funding is very often the key asset to attract investment or to get a loan. The pricing for cookstoves can vary a lot, 5 to 35 euro per ton. I put here like cookstove projects are normally seen as premium credits because they have very important co-benefits. They normally address a poor population, they reduce smoke and improve health, they can reduce domestic labor. But there have been headlines already mentioned in presentations before. Just 2 years ago, there was a study that found that there's massive overcrediting in cookstove projects. They claim more carbon sequestration than they should, which is simply true, I must say. So I will now talk about the methodological aspects that can explain how this overcrediting can happen. This is, well, somehow damaged the market, but it's also a healthy development because now there's a higher focus on quality, and some projects can also like present themselves as high quality projects, like the Ecosafi project in Kenya made headlines with selling credits for 35 euro or dollars per ton, which is very high for the voluntary market. The prices are very different in the voluntary market and the compliance market. So this is normally you have like 5 to 15 euros, as I said. So this is possible now to show that you are producing quality, which you have to show, and which means that you get less credits per stove, obviously, because you cannot do that over-crediting. So I'm talking about the methodologies that gives you some practical insight. The baseline has to be defined. That's the emissions that would be caused by cooking with traditional stoves and fuels. In any case, with cookstove, the most carbon is saved by increasing stove efficiency. Example of the Supermoto stove with pellets. 1 kilogram of pellets can replace 1.6 kilogram of charcoal, which would be used to cook on a traditional stove in terms of cooking energy, useful cooking energy transferred to the pot. So even though charcoal has a much higher energy content, the Supermoto stove, the gasifier stove, is much more fuel efficient. So this explains that ratio. The overcrediting can happen or happens and continues to happen easily if baseline consumption is overstated. Many projects use some sampled tests, which are called to be representative, but it's hard to prove that they are really representative. They may neglect the fact that people are in the baseline not only using charcoal, but maybe also some LPG or a lot of LPG in urban contexts. They may also neglect that some people already have improved cook stove from other projects. So the baseline should be those new baseline stoves with higher efficiency. So this is all different factors that can lead to overcrediting. And unfortunately, there's a very strong incentive for project developers to maximize credits, because that's maximizing project funding. There's a methodology which I'm using for those gasifiers and pellets, which is the gold standard methodology for metered and measured energy cooking devices. This is recognized as a methodology with better accuracy and better quality. And it, for example, it requires you to really consider all the different baseline technologies that are being used by users, because it's quite common that users have not one single stove, but they may combine LPG and charcoal, for example. Very highly debated factor is the so-called fraction of non-renewable biomass. If I'm saving fuel wood, because that's also quite exceptional in the cook stove projects, that emission reductions are by replacing biomass and not by replacing fossil fuels. So the question is, how unsustainable is that biomass? If I'm replacing renewable biomass, I would not get any carbon credits. There was a simple tool in the CDM that everybody who's good with numbers was able to show some more than 80% of unsustainable biomass, like pretending that only a very small part of the wood that people use in the baseline will regrow. So this gives you more carbon credits. Now this has changed, and there are new default values being introduced by CDM, which is then also binding for most voluntary standards like the gold standard. And these values are dropping a lot. They have a better scientific basis. Now it's rather 20 to 50%, which directly translate into a reduction of credit yield. Drop from 80 to 20% is 4 times less credits. So this is significant. Details are still being discussed, such as if FNRB values can be higher in cities that use a lot of charcoal, which is sometimes imported from other countries. It's a complicated situation because the rules are changing and the market has to deal with it. Regarding monitoring, normally cook stove projects are monitored with sample surveys. You just pick a random sample, go and visit the users and look, are they still using the cook stove you gave them? And are they still using the other stove, the traditional baseline stove they have been using before? And this is also quite difficult to get accurate results, and it's quite easy to get, over optimistic results regarding cook stove usage. Under the gold standard metered methodology, you can directly monitor the supply of pellets. So you exactly know which user uses how much pellets, and this directly tells you how much does he really use his stove. This is accurate and very different from normal conventional cook stove projects. And you can have it more specifically with remote usage. You can record the fan speed and have heat sensors. This is what is done also in these projects with gasifiers and pellets. Unsurprisingly, you find that if you are accurate, your results are lower. You find a lower usage than you find in other projects that do these representative surveys. But the transparency and accuracy helps you to get better prices, as mentioned. Another complicated question, and very relevant also, for example, for yacht, I guess, with the pellet production. In the project I'm working with, most pellets are produced from sawdust, which is considered waste biomass, which needs to be shown. It really needs to be left to decay. If there's a market for sawdust and it's used as a fuel, then you also have to regard the pellets as if they were just normal wood, because they are like a part then of the biomass fuel market. Still, you can then earn carbon credits, but a little less. And under CDM, it's quite strict. Dead biomass in the forest is not renewable, not residual. And in practice, however, normally in the voluntary market, it's not very strictly applied, these criteria. If you produce your own biomass, just like yacht is doing, then it's possible, but it's also complex, and you have to show that you are indeed producing sustainable renewable biomass. And you have to take into account like competing land uses. If there's cows on the land where you're planting a biomass, you need to take that leakage into account, use of fertilizers. It's possible, but it's not easy. And Henrik will know more about it, I guess. Then you have to consider project emissions like electricity and transport of pellets, which is not really significant. It's a very small part of these emissions that are then discounted in the end. You have some quality labels, some rating agencies that are mainly working for the voluntary market and check individual products like B0, Calyx Global. Then overcrediting is often punished by bad rating, but the only A-rated product that exists, as I far as I know, in the B0 is EcoSafi in Kenya, a pellet stove product. And there are the so-called core carbon principles for the voluntary carbon market. These are criteria introduced that rather check generally methodologies and certain emission factors used by the project and make them eligible. This is starting now also for cook stove projects. And to be eligible, you need, for example, to apply a low FNRB value and be conservative. Quickly summarizing, carbon credits are very important for cook stove projects. This also implies a risk because some projects are rather producing carbon credits and not primarily trying to improve a cooking situation for people. Such projects unfortunately exist. With low quality cook stoves, normally, carbon market starts to demand quality. This means less credits per stove. Cook stoves with biomass fuels, such as gasifiers with pellets, are technically quite advanced and allow for very individual usage monitoring. They often target urban markets where you also have to check that you should really be aware to replace charcoal cooking and not compete with LPG and electricity, which would not have a positive effect on the climate and should not generate carbon credits either. And the new framework under the Paris Agreement is also interesting and will replace parts of the voluntary market and is also demanding quality, which is a chance for high quality products. That's it. Thank you very much. And I'm looking forward to the discussion if there's some time left. Are you mute, I think?
Oops, sorry.
Yes.
I was unmuting myself and at the same time I was unmuted, so I was muted again. Happens. Robert, thank you. That was very illuminating and useful. I mean, one of the questions that came up is how, it's from Thomas de Weil, how difficult is it to enter into offtake agreements for the pellets, especially in the startup phase where you don't have high volumes? So this chicken and egg problem, how are you going to produce pellets without knowing who is going to pay for them? And also, how are you going to raise carbon money in a situation where you kind of have high upfront costs for certification, etc., and where you really need the money before you can actually produce the credits for investing into your supply chain, for selling startups and the likes. Can you elaborate a little bit on that? This startup issue is a really difficult one for many projects.
Yeah, it is difficult, but it's common practice. It depends. You need to be able, normally you need to set up some pilot project where you can show that you prove that there's a proof of concept. Then it's quite usual that you can find, it depends on your ability to convince investors, but it's usual that investors pre-invest in such cook stove projects and then step by step increase the investment. There are also like upfront purchase agreements where you can already pay a part for the carbon credits that you want to buy from the project. So it's really common to get funding upfront, but it's not easy. And it's easier for big projects, obviously, with a high rate of credit return, which is also another incentive maybe to maximize carbon yield, which can be problematic, as we've seen.
I'm seeing a lot of questions that are still relating to the concept of growing biomass as a feedstock for using biomass. As a matter of fact, I mean, we have very recently tried to collect the data from all pellet production projects in Africa. We found about 20 to 30 projects, more than you might think of. And we noticed that most of the projects are really using residues. The majority is using woody residues from wood processing. And then some are also using, for example, residues from the sugar industry, bagasse that is not used in the industries in some countries like in Kenya, but also in Uganda. There are huge landfills with bagasse that basically is decomposing there, not being used, and that is of course a fantastic and also very cheap biomass that can be used to produce a clean fuel instead of charcoal that is leading to deforestation in these countries. So there is really a big scope of environmental benefits, and it is mainly related to replacing charcoal because charcoal is so. I'm sorry. Because charcoal is using so much wood. There is about 8 tons of wood that you need to produce 1 ton of charcoal. That's the statistics for Rwanda, at least, that I know. So let me see if there is another question for you. Yes, there is a question here. In previous webinars, it was mentioned that Supermoto would install some kind of sensors in the stoves would allow to obtain certain metrics when operating the stoves. This would allow them to actually calculate the amount of CO2 generated by the stove and display it in the app or on the website. Is this already taking place? That's the question. Robert, you should know.
It is taking place. Actually, it's a methodological question. Like it's double safe if you base carbon credits, like methodology bases carbon credits on pellet usage, which I think is also maybe even the best metric, because you are able to make sure that pellets are only used in the stoves. People don't have other reasonable uses for those pellets, and they personally buy the pellets. So this is like the first source to calculate the carbon credits in accordance with the methodology. But the real-time data, well, that it gives you, like, it makes it double proof, and it can also help in practical questions to find out if data don't make sense, or know even more about your users. So both are used, but primarily it's pellet sales due to the methodology.
And the sales can easily be tracked by the records by the financial records, fundamentally.
Yes, because the project itself is providing the fuel. It's like a service system. Like the stove is been given to the user for free, but he buys then the pellets. So it's like an energy utility concept they are applying.
There is another question on how big is the overall voluntary carbon market? Can you give overall?
I would have to look it up. It's also a difficult question because there are very different standards with different project qualities. Think of the RED Plus projects that are claiming to avoid deforestation. Such projects easily produce 10 millions of credits per year and make up a huge part of the voluntary carbon market. If you just look it up, State of the Voluntary Carbon Market, it's like a publication that comes out every year. It gives you all these figures in much better quality than I could try by guessing.
And a part of the overall size, do you see that there is a trend towards increasing demand, or do you see a trend towards decreasing demand?
It's also difficult to tell, like the criticism on quality for cook stoves, but also on the mentioned RED Plus project that affected the market and led to market reduction. Now the market is recovering, but very important will be what happens under the Paris Agreement, because there will be like a new CDM, a new mechanism, which is then under the Paris Agreement, which is then not a voluntary market in that sense, but has a better control, and that may take over parts of the voluntary carbon market. And also some countries are starting to put taxes on credit generation in their country, because as was mentioned in the beginning, they are not willing just to let investors take the carbon away, which they would then have to account for in their NDC. So there's uncertainty, but it's currently staying a big market.
I mean, what I've heard is that the deals that are being done with countries that are purchasing carbon credits are much more lucrative, and they provide much more stability. And I think some of the countries are readily signing these agreements to hand over the credit rights, because it will actually benefit their population if these projects take place. So they have a kind of a
it happens, but it's evolving. It's just starting, and
yes.
It's much less than currently the voluntary market.
But saying that it is evolving means that it can also become pretty big.
Yes, yeah, but very hard to say. I think it will never have the quantity of different projects that are there in the voluntary market, and the voluntary market will keep on existing. But in certain countries, it may not be possible anymore to do a voluntary carbon project. So it's hard to say. There's a lot of dynamics ongoing, but I see still projects are using the voluntary market as before, and this still is happening and not really decreasing.
Excellent. Then I would like to thank our speakers. I would like to thank the audience for joining us, and remind you that we have a series of coming webinars that also will be very interesting. So have a nice day, all of you. Thank you, and see you the next time. Bye-bye.
Thank you.
Thank you very much. Bye-bye.